Yeah, Chiara had a family thing, so I'm filling in for her. So this will be a little bit this will be a lot of bit unrehearsed. Okay, Chiara, part of Chiara's thesis is she had the insight that we have methane in the lunar atmosphere, and that was shown by Dick Hodges to adsorb on the night side. So some amount of that methane will be migrating to the poles and may accumulate as adsorbed methane. So let's see what we got here. Okay, so here's the plot on the right of the methane concentration, which is essentially zero at the night side. There's a spike when the sun comes up, and then that decays. There was also the LACE experiment found a peak corresponding to methane, and then there was also methane found in the Apollo 11 and 12 finds. So methane is a thing. Methane is the new water on the moon. Okay. Um, okay, so the point here, the PSRs have nighttime temperatures or below, so they're ideal for trapping methane. Um, there's hydrogen detected by Lunar Prospector, so part of this work is to determine what fraction of that hydrogen detection by Lunar Prospector could possibly be due to methane. And then finally, Regolith Overturn may turn to further sequester the methane in the uppermost regolith. Um, let's see, Chiara wanted to make the point, I won't belabor it, but she did some calculations just to sort of put to bed the notion that methane may actually condense. Methane will not condense at lunar temperatures. The coldest of the cold traps at night are just long enough to keep it for geologic time, but when the coldest of the cold traps get to their warmest temperatures, methane is just gone really fast. So there's no condensation of methane. Um, so Carrick calculated the how much methane can be absorbed to the surface area of the moon as measure of lunar soil as measured in a laboratory. So the bottom line is a monolayer of methane on this would be about 100 ppm of methane and about 27, call it 30 ppm of hydrogen at 100% coverage. Um, then working with Emily Costello, they calculated how quickly regolith overturn could sequester methane. So over a reasonable depth in the regolith, deep enough to be sensed by Lunar Prospector. And I'm skimming over this because I'm not familiar with it. But the bottom line is, let's see, was there a bottom line here? Yeah, okay. So the bottom line here is over about 10 to the fifth years, you can totally saturate um, both the intense reworking zone, which is about 10 centimeters, and then down to about 30 centimeters. So the methane can definitely be contributed to the whole column of that's sensitive to Lunar Prospector. Um, Okay, so this is all right. So this says that's stated. So the bottom line is that about 20% of the hydrogen signal could be detected uh, by Lunar Prospector, could be accounted for by methane. Okay, so we have to X out Viper. Actually, the famous Casey Honeyball was going to test this hypothesis by degassing the regolith with the nervous or the Viper illumination lamps, and then use them solo to watch the methane wind come off. But Trailblazer should be able to detect a 3 micron methane band in permanent shadow. And Casey calculated a few percent deep band if the optical surface is saturated. Let's see. Okay, we're going to back up here and let's see. Did I have one more unnecessary comment to make? Oh, yeah. So there have been some models at the School of Mines for extracting water vapor from the lunar regolith by putting basically kind of a little circus tent on the regolith, and then illuminating that with lamps to heat it up, and then letting the ice vaporize, and then would pump that out. When you do that, you're going to pull this methane out. So methane's a popular fuel, as we've heard today from many of the rocket people, and so the abundance is about from a 10 centimeter cube of regolith, you can get about a gram of methane. So it's a fairly large quantity of potential methane that you can extract from the surface. And thank you.